And now for the short answer part of the proficiency. So it says Justin's parents are trying to encourage him to start saving for college. To show how quickly pennies can add up, they offer to start saving pennies in a jar. They'll give him 1 penny the first day, 2 the second day, 4 the third day, and continue to double the previous day allowance for 30 days. So A is asking us to create a table to show the number of pennies placed in the jar for each of the first 10 days. Now, remember, if you missed this, what you should be doing right now is copying down the work on your correction sheet, and then in a minute, you need to stop the video and then say what is wrong with your answer. So I'm going to make my table here. So this is days. This is number of pennies. So I know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 days that we're talking about here. So that's going to be the first row, or first column, I guess. So it says on the first day he got 1 penny. So day 1 should be 1 penny. Day 2, he got 2 pennies. Day 3, he got 4. And it's saying that they continue to double every time. When you double something, you're multiplying it by 2. So you'll notice that 1 times 2 gave me the 2 for the second day. 2 times 2 gives me 4 for the next day. So 4 times 2 would give me the next day, which is 8. Doubling does not mean adding 2. It means multiplying by 2 every time. So since 4 times 2 is 8, 8 times 2 would be 16. 16 times 2 means I'd have 32 the next day. Times 2 again would be 64. Times 2 again would be 128. Times 2 again would be 256. And finally, on day 10, going to be 512. So the way the scoring for the ERQ worked, this is out of 2 points. So if your table was correct, remember a table is just this list. Some of you guys were making a graph of what this looked like. Okay, a table is just like what I just did. So I'd have 1 column with my days, 1 with my pennies. So it should have looked like this. So you got 1 point for getting part A right. Part B says, is the relationship linear? Explain why or why not. Remember, if you have a table, well, you actually have a couple of different options. So one thing you could have done is, and I'm going to use this grid right here to kind of make a little graph, is you could have graphed them to see whether or not, remember that the word linear, make a little bit better graph here. Remember that the word linear means that if you were to graph it, it'd form a straight line. So my days would be here across the X, my number of pennies would be right here. So at day 1, I would have 1 penny. So I would have a point right there. At day 2, I would have 2 pennies. So there's my 2 right there. Okay, so far it is looking linear. Day 3, I would have 4 pennies. So I'd go up 1, 2, 3, 4. Okay, notice already just at day 3, I can see that if I start graphing those, this is not going to be linear. So for part B, I could have said no, because if I graph the table, it won't form a straight line, which would make it not linear. So that's one thing I could have said. For part B, so I could start graphing my days and my number of pennies, and I would see just after doing the first 3 days that it's not going to be linear. So that's one thing I could have said. Also for B, remember that when you have values in a table, that you don't even have to graph them to see whether or not they're linear. You can just look at the rate of change. And remember that if it's a constant rate of change, then it's linear. So all of your x's are all going up by 1 every time, because every day is going up by 1. From 1 to 2, it goes up 1 day. Then it goes up from 2 to 4, it goes up 2. Then from 4 to 8, it goes up 4. So I can already tell right here that my rate of change is not constant. So for part B, you had two choices for your answer. You could have said no, because if you graph the table, it won't form a straight line. Or you could have said no, because the table does not have a constant rate of change. Now, what a bunch of people said, I noticed when I was grading these, is that they were saying that because you're multiplying by 2 every time as you go up, that that's a constant rate of change. Remember that rate of change, you're not multiplying by the same number. In order for it to be a constant rate of change, you need to be adding by the same number every time. So from 1 to 2, that's going up by 1. From 2 to 4, that's going up by 2. So you got to be able to add the same number every time for a constant rate of change, not multiplying. So for part 1, this is what your table should have looked like. For the second part, you should have said, no, it's not linear for either of these two reasons. Either you graphed it and it doesn't form a straight line, or you do not have a constant rate of change.